All right, so here we are, our second page. The idea is there's got to be a faster way to get these terms. So if I say find the first term, find the second term, find the third term, that's fine. You just multiply Abby times your common ratio. But if I say find the 50th term, then it gets a little harder. All right, so here's our little rule. We're going to be using our calculator for exponents. So once again, if you don't have your calculators out, get them out. If your cell phone has exponents on it, get it out. But here's our rule. A times little r raised to the n minus 1. Okay, that's our formula for the value of the nth term. From common differences, do you remember what the A stands for?
First term.
Okay, I've written it down here. That's the first term. Little r is the common ratio, and n is the term number. So let me just kind of walk you through a couple examples. The first term, negative 2 times 3 to the 1 minus 1. Where did I get that 1 minus 1 from? Well, the nth term, that means we want the first term. What's 1 minus 1? 0, okay? So I have negative 2 times 3 to the 0. What's being raised to the 0 here? The 3. Anything to the 0 is 1. So negative 2 times 1 is negative 2. Now, that seems like a lot of work.
How can you generate in your calculator? It comes out as negative 7.
Interesting. Let me put it in. Let's see. Negative 2, whoops. Negative 2, can you see it on mine? Times 3 raised to the power of parentheses 1 minus 1, close parentheses. Why do I need those parentheses there? If you don't put the parentheses there, it's just going to raise it to the 1 and then subtract 1. So I'll show you the difference. There's negative 2. Now, if I do the same thing, negative 2 times 3 raised to the power of 1 minus 1. Now, why does mine do it that way? Where is it keeping my minus 1? It's keeping it as an exponent. I'll bet you on your calculator, when you do the upward arrow, it just makes a large one, and then the minus 1 is in the same size. So this is called math print. It's a function in the TI calculator which says, hey, I'm up in this exponent idea, and it's not going to bring you down unless you force it down with an arrow. You know, you got to be able to do an arrow over and then minus 1. You really got to make it work to do it wrong. Now do we get negative 7? Because now what is it doing? It's saying negative 2 times 3 is negative 6, minus 1 is 7. So on your calculator, you're going to have to make sure you put your parentheses in. And Luke, that's why I'm not wild about those calculators to some degree, because it doesn't show what you want it to show. So you have to put an extra parentheses to really make sure the grouping is correct. John?
I wrote the exact same thing on my calculator.
Uh-huh.
And I got 6.
You got 6? Interesting. Let me see what you wrote. Okay, I'm going to show you John's calculator. Let's see if we can compare them and see the difference. Do you see any difference between those two?
Yeah.
Well, you did the same thing with your bottom line.
Right here, see this sign? That minus? You see this sign? What's this sign? That's an opposite of 1. See, it's taking yours, and without even putting a division sign in, because you put an opposite there, it's assuming that you're taking this first part and multiplying it by the second part. Because an opposite, so it's kind of, it's weirded out. It doesn't know what to do with what you gave it. Because you're saying negative 6, opposite 1. It doesn't know. It says, okay, that's incorrect syntax, it's incorrect usage, So I'm going to assume that you think multiply. Now what it should probably do and throw back at you is like syntax error or some kind of, input error or something saying, hey, we can't put it in like that. So that's why you got to be careful in what you're doing. The opposite sign and the minus sign are very different. On some people's calculators, doesn't it throw back an error at you when you do that? So we just got to be smart enough to use our calculators and things like that. So, okay. But that's okay, because that notates you and tells you, hey, I made a mistake here. All right. Now, what did I tell you up here in this formula? What does the A represent? Look at our formula here. What's the first term? -2. Do I need to do all this work? No. Look over at the second formula. 4.3 times -3 to the n minus 1. If I ask you what the first term is, how do you answer? 4.3. Okay? I don't want you to do work. I don't expect you to do work. And I really would rather you didn't do any work. I want you to recognize, Luke, that the first term is pulled right out of the formula. Now, if you forget that little shortcut, we can always go back and plug it in just like we did. But John, we got to be careful that we're plugging it in correctly. So, use your calculator right now. Plug them in to make sure we're comfortable with your calculator. If you don't have one of these and you still want to get one, it's very worth your while. Okay, they're like $16 at Target or Kmart or Office Max. All right, here we go. -2 times 3 raised to the 4 minus 1. Let's try without our calculator here. And then we'll check it. 4 minus 1 is obviously what? 3. Okay. 3 cubed. Can you do that in your head? Good, John. 27. And 27 times -2. Nice. All right, everyone try that on your calculator. Make sure you get a -54. Punch it in right now. Because one of our goals is to make sure that we're getting on this. Because you're subtracting this. This is 4 minus 1. You put the opposite. Put parentheses.
I did. It says.
All right, so you may need to do the 4 minus 1 first and do a little bit more in your head. Because the beauty of this is you can plug it in exactly as it says. So, all right, let's try the next one. -2 times 3 to the 5 minus 1. Are we done? How did I get that so quick? Look up here. How did I just write down 108? Thank you, Jalan, student of the day. How did I get this 108? Because I recognized the fact that the common ratio was what? -2. I have the fourth. To get the fifth, all you do is multiply by -2. Now, did anyone crunch it all out?
Yeah.
Did you get 108?
No.
Ooh,
-162.
scary.
Yeah, that's why I did too.
So why am I wrong? What should I have multiplied by? Why is it -162 and not 108? What is the -2? Is it the common ratio? What's the common ratio? 3. Okay, so I'm trying to help you see there are some shortcuts that we can take, but we got to be careful with them. Or you can plug it straight in and get our answers. All right, let's go over here. Decimals, we're going to need calculators definitely. -3 to the 4 minus 1. Maybe you can make some shortcuts there and assume, 4 minus 1 is 3. So take your calculator, 4.3 times, in parentheses, make sure this is in parentheses, -3 to the 3rd. Plug that in. You should get a decimal. I get -116.1. Can someone confirm that for me? All right. Okay. And our last one, 4.3 times negative 3 to the 5 minus 1. How much? 348.3. Can someone confirm Luke? Haley, that's what you got? Okay. So, finding a geometric sequence. Plug in your calculator. A times r raised to the n minus 1. That's your formula as we try to look through these. Yes, sir?
So the A, the first term,
Uh-huh.
that's just the first.
That's the first term.
Well, basically, so you're just starting with the first term.
Right. So if I just give you a formula, and I say the formula is 16 times 3 to the n minus 1, what can you tell me instantly? The first term is 16. The ratio is 3. So I'm telling you what that stuff is, but I'm burying it in the formula. So I want you guys to be wise enough to say, oh, here's the formula, but I can also pull information out of that formula to make life easier for me. All right, here's our last one. Write a rule and then find the given term for the following geometric sequence. The first term is negative 4. So put a equals negative 4. The common ratio is 2. So put r equals 2. Can anyone think they can take that information and give me the formula? Mr. Lanham, go ahead.
So do negative 4 times 2, or well, yeah. And then do the 12 minus 1.
Well, the general formula would be n minus 1. Okay? And then for yours, we're finding the 12th term. So I put a of 12th. That means like the 12th term. Negative 4 times 2 to the 12 minus 1. So I think this is going to be a huge number.
Negative.
2 raised to the 11th. Wow. Negative 8,192. That got up there in a hurry. Why? Because you're raising it to the 11th. That's a lot of times 2, times 2, times 2, times 2. So geometric sequences should be really straightforward. The key is really remembering how it ties into this formula. That's the first one. That's the ratio. And then remember on the previous page, to see if something's a geometric sequence, what we're going to do is divide the second by the first, or the third by the second, etc., etc. Okay? All right. What's up?